So, hello everyone. Today we are going to discuss about the measure and the matrix, which involves how to estimate the requirements that we have already gathered in the previous exercise of requirement engineering. So, to start with, let us discuss the two definitions of the term called measure and the term called matrix. Measure generally is a quantitative indication of the extent, amount, and dimension or size of some attributes of a product or a process. That means it is a single data point. So you can say that I have size, I have weight, I have length. These are all measure. And how we use measure is with the help of measurement. I'll compute this measure with the help of an activity which is known as measurement. Now, what is matrix? Matrix is the degree to which a system or a component or a process possesses a given attribute. That we want to say what is uh, the average strike rate of a batsman. So we have to find two measures and the relativeness between these two the degree to which one attribute is related to the other attribute. It relates several measures like average number of errors found per person hour. That means it relates multiple measures, and we can relate two or more measures and find out what the matrix is and why this. So we once we do understand what is matrix, the question is why is the matrix so important? Because it helps software engineers to better understand the attributes of models and assesses the quality of the software. It tells us something about the software, whether we are developing the right product or whether we have less errors per development cycle and whether we are going in the right direction. It also helps software engineers to gain insight into the design and construction of the software. Further, it focuses on specific attributes of software engineering work products resulting from analysis, design, coding, and testing. So, at each of the level of each of the phases that we already discussed as a part of SDLC, we found that each phase gives out certain work products. Now we have to assess these work product whether we have developed a sound work product or not. So this matrix helps us to find the specific attributes amongst this particular different type of work products. It also provides a systematic way to assess the quality based on a set of clearly defined rules. So with the help of values, we can actually define, we can assess the quality of the system itself. Some examples of day-to-day working and living metrics that we generally compute as a part of our daily activities can be like cost of utilities for the month, cost of groceries for a month, amount of monthly rent per month, time spent at work each Saturday for the past 2 months or for the past month, time spent mowing the lawn for the past two times. So these are certain set of matrices that we generally compute. Some of the matrices, some general matrices that we generally compute in the day-to-day life. So likewise, can student can also create his own matrix. So if I can say that if I ask you to write some examples of the matrix for a college experience, you can jot it down certain matrices. Okay. So here you can stop this video and you can just think about it. What can be the matrices that you generally create? Some of the examples I'm giving right now uh, is equal like grades received in the class last semester. So what is the grades received in the last semester according to what is the hard work that you did in the last semester, number of classes taken in each semester, amount of time spent in class this week, amount of time spent in studying and homework this week, or number of hours you sleep at night. So these are some of the matters that you can create, or some more matters you can think of related to college experiences. Now coming to the types of matrix, so they are broadly divided into two basic types. One is called direct matrix and one is called indirect matrix. Direct matrix generally type to read and type to use immediately measurable attributes such as line of code, execution speed, defect reported. These are something which we actually can see and we can actually measure directly. We use those particular attributes. But other than this, there are certain more attributes which are more abstract in nature and which cannot be measured directly. So they come under the indirect metrics such as functionality, quality, reliability. So functionality can be good or bad depending upon certain scenarios, certain circumstances, person to person. The quality also varies person to person. Something which is very good to you might be a very bad taste to me, or something which is more reliable to me might be totally unreliable for you. So it depends upon the scenario and the person. It's very subjective in nature. So it is they are not immediately quantifiable. That's why. So we are going to actually work on basically the direct matrices in this particular course, and we will see how we are going to use the direct matrix is through the technique which is known as the concept which is known as software sizing. Software sizing is an activity in software engineering that is used to determine or estimate the size of a software application or a component in order to able to implement the software project management activities such as estimation and tracking. So software sizing, why is software sizing so important? Because we are estimating the size of a software product before the design has started. Okay, this is the most important part. Crucial part is this, that you want to estimate something even before you far before then you start coding. Okay, so and this estimation which really helps you in allocating the resources as well as setting up a tracking plan. Like weight is an inherent characteristic of any tangible material. Size is an inherent characteristic of a piece of a software. So every time we try to assess a good software or bad software, or a good style of writing or bad style of writing, we take into care the size of that software. So depending on this, software sizing matrix can be divided into two basic categories. One is called size oriented matrix. One is called function point matrix. So we will go one by one in both these cases. We will first of all see what is size oriented matrix and what are the drawbacks of the size oriented matrix, and that leads to the development of the function point matrix. So we quickly cover the size orientation matrix in this slide and this video, and next we will go through the function point matrix. So in the size oriented matrix, this type of matrix use the estimated effort and development time by using lines of code. Sample size oriented matrix will be look like this what is shown on the slide. It has lots of attributes related to some projects like alpha. The LOC is 12,100. The function point value, they leave this thing right now. It is not defined right now, but understand this is lines of code is suppose 12,100. The effort per person month is 24. The red value is come to 168,000. Then the documentation that was done for alpha was 365. The errors that was caught was 134. Out of these 134 effort errors, the error that it was ignored or that was gone through by the production cycle and was caught at the end of the cycle of the by the customer was 29, and the people involved was 3. Okay, so likewise I can have multiple type of estimation for this particular size zone. So somebody has to do some estimation based on our previous experiences. So size orientation matrix generally involve a pessimistic approach and an optimistic approach to estimate the size of a particular software. So the orient matrix generally can be an errors per lines of code, defect per lines of code, rate per lines of code, page of documentation per KLOC, errors per person month. lines of code per person month, and rate per documentation. So some of the metrics that belongs to this category of size-oriented metrics are noted down here. There may be many more matrices which can be used as a part of a project development system. Now, the drawbacks of LOC. Uh, Let us understand first what is LOC, then we come back to drawbacks. So how do we compute this LOC? The size of a source code is computed by considering the optimistic, most likely, and the pessimistic value. That means if you have developed a certain scenario, certain code in a particular piece of time, then you will be actually able to tell us roundabout the correct value of how many lines you can use for coding. And if somebody who haven't done that similar program or that type of program in his life, entire life, and I ask him, so to be a safer side, he gives a larger value. Okay, so these two are called the optimistic and the pessimistic approach. So we will take these two measures of optimistic and a pessimistic approach, but we actually work with people who actually did a lot of similar work. Okay, so we actually we multiplied this value, which is most likely with a weight of 4, so that it is much more larger than these two weights, which are on the other hand of that likelihoodness. So what we do, we create an average, weighted average of the size, and we compute the value called S. Okay, this is how the size orientation matrix works. Suppose the optimistic people who has actually worked give us a value called 1000 LOC for a particular set of problem, and the pessimistic person who does haven't worked on such a part per problem give us a value called 2500 LOC, and the most likely gives you 1500. So once you put these values back to this formula, you will get a particular value which is most likely related to actual value of 1500. Okay, so when you put it in this formula, we get 1583 LOC. Okay, so this is how you estimate the LOC. And when you found the LOC value, okay, now you can use this LOC value to estimate the future development. This is what is the code will look like. Okay, this is how we say that we will develop a particular problem in 1583 lines of code. Now, what is the number of what is the total cost if we want to find out what is the effort that will be required to develop such a large code? uh, we can estimate this with the help of a historical data. So we need to have an historical data. We say that the average productivity of a system was 620 LOC per month, and labor rate was 808,000 per month. Okay. So if you see these two values and you relate this system here, we say that uh, productivity, the rate divided by the productivity is the line, the cost is the cost. Okay, so actually these two things is giving you this value. Okay, these two things is giving you this value. Actually this is resultant of dividing 8000 per 620. Okay, so you got cost per LOC. This is how cost per lines of code, this is how we get. So if I ask you to create the find total estimated project cost, what you will do is you will have to first find out the LOC, okay, the cost per LOC, that is $13, multiplied by estimated LOC, that is 1583. So you will get the complete cost of the project. Now, once you have the when if you want to estimate the effort in person month, then what you need to do is the estimated LOC should be divided by the productivity of the system itself, and you will get the total person month, the 3 person months, and the total cost is $20,579. This is how you estimate based on the size that you have calculated. So now we can see what if we actually find the cost and the effort, They, why we choose another method? We choose another method because this size-oriented matrix was having certain drawbacks. The LOC measures are programming language dependent. That means when the productivity is considered, they penalize the well-designed but shorter programs. So size is a very important factor when we talk about size orientation matrix. The lengthier the code, the more the effort will be. So if you are a good programmer, you optimize the code, you will get a less amount of efforted value and less cost to the company. So you will be penalized for that. Secondly, the LOC measures are also dependent on the level and skills of the programmer at large. So, if somebody is a poor programming skill, he will develop the same code in the larger set of values, LOCs, and somebody who is experienced has a very good programming style, so he will develop it in a very shorter period and shorter lines of code. So, it is actually dependent on the programmers. So these two things led to the development to the migration from the size-oriented matrix to the function point based matrix, which we will see in the next video lecture. Thank you very much.